Okay, this is an awesome turnout. This is great. Thank you all for coming out and joining online. So this is a short talk about identifiers, database identifiers, and specifically Stripe style prefix IDs. So a little bit about me before we jump into the fun stuff. I currently work at a small startup called Freshline. We're actually just down the street. We're like a food service kind of SaaS, and we just started using Elixir and Phoenix, which is pretty exciting. I love most things to do with food, like cooking and eating. If you have thoughts about the best burger or the best slice of pizza in the city, then we should probably chat after this. Pizza is one of my favorites, by the way. I'm fascinated by a lot of nerdy things like languages, type systems, compilers, virtual machines, and CSS, but I know virtually nothing about any of those things. My favorite part of the computer is the screen, and now you know pretty much everything about me. Okay, so let's talk primary keys. We're going to be focusing primarily on relational databases, but we'll also briefly draw inspiration from a document database. A lot of this you might know already, but I'm just going to cover it all just in case. It's mostly for my benefit. A primary key is an immutable attribute that uniquely identifies a set of data. An example of this could be our social insurance numbers, if we were all rows in a table somewhere. Over the years, our choice of data type for primary key has grown. So we have a lot of different choices. And so we're going to go over a couple of those to see what they are and what they do. So integers are probably the most common type of primary key in the relational database world. You usually see them represented as 64-bit integer sequences. So starting from 0 or 1 and counting upwards. They're both simple and easy. They're fast. They're space efficient. They're naturally ordered. And the database can generate them for you. Why would we ever use anything else? That's a great question, and I'll tell you why. These sequences are predictable. People and computers can infer information about your system based on these numbers. They're not opaque to users, which again can leak certain information about your system. Because they're sequences and primary keys are immutable, there can be gaps. So for example, if rows are deleted, like rows 1, 2, 3, 4, you can't reuse 1, 2, 3, 4 again. So you can have large gaps in your data set, which could be problematic. And finally, since our database is the one responsible for generating these primary keys and this sequence, we won't know the value until we actually put in the database and then ask the database what it was. So to be fair, most of these problems are not actually problems. In most cases, integers are perfectly suitable and you should definitely use them. But it's important to be aware of these problems and some of the alternatives. So after integers, we land on UUIDs, or a universally unique identifier. They are 128-bit random values, typically represented as a collection of hex digits. There are a few different flavors of UUID, each with their own unique recipe for uniqueness. Most popular databases have native support for UUID built in, which is pretty cool. You'll probably see UUID v4 mentioned the most, which is the fully random version. So everything, all 128 bits are completely random. So why do we like them? Why are these good? They're opaque to users. They're larger in size, but they grow linearly, which is pretty cool. And they can be generated on the client side. So before you even hit the database, which is pretty awesome. However, they have a few problems. They take up more space. They can be slow to generate, especially the fully random ones. And they're not naturally ordered, which means we can't sort them, which is a big problem, especially when you're doing things like pagination. So next up, we have object IDs. Stepping away from the calm safety of our relational world and into the veritable hell of MongoDB, we come across object IDs, a new type of identifier. On screen, you can see an example of an object ID there. Object IDs are 12 bytes, and they consist of a 4-byte timestamp, 5-byte random value, and then a 3-byte serial counter. Object IDs are notable because they share all of the pros of UUIDs, but they're also naturally ordered, which means we can sort them and maintain sortability in our database. The cool part about the 3-byte serial counter at the end means that if we have millisecond level collisions in terms of the time, we can increment the counter so that we can essentially support more ID generation within the same millisecond, which is not super common, but a cool problem to solve. So despite all of MongoDB's complexity, I actually really like object IDs. I think it's something that MongoDB really got right, and it's something I miss in other databases. So returning to our relational world, we finally land on ULIDs, or universally unique lexicographically sortable identifier for short. ULIDs are essentially a combination of UUID and object ID. They are 16 bytes long. The first 6 bytes is a timestamp or a 48-bit integer. The remaining 10 bytes or 80 bits are cryptographically secure randomness. So just completely random garbage in there. They also have a sequence counter built into that as well, if you need it. UUIDs are exciting because they're compatible with UUID, which means all modern databases already support them out of the box, which is pretty neat. They're lexicographically sortable, which means they're just sortable as we would normally sort words, which means we can still use it for things like pagination. And they're represented as a 26-character URL safe string, which is base 32 encoded. Base 32 is an encoding mechanism invented by Douglas Crockford, the JSON guy. And he essentially just removed all the unsafe letters from the alphabet, like I, L, O, U, to prevent like different types of hacking, like social hacking. Like I and L look similar to ones and stuff. And they're really fast to generate. So UUIDs, and here's an example of one there. They're pretty cool, but can we make them better? And the answer is yes. Most of the advantages that we've been talking about so far have been for the benefit of computers and the system indirectly, like pagination. But what about us humans? I'm sure many of you have encountered an ID without context is next to useless most of the time. It's very easy for context to go missing in things like logs, bug reports, customer emails, and someone slacks you an ID of something you need to check out. You have no real information about what that is without following up or hoping that they provided it. So something really cool that Stripe did, oh man, those are pretty small, I'm sorry. Hope you can see those. Something really cool Stripe did is they added a human readable string prefix to their IDs, which identifies the resource type of the ID. For example, payment method ID will start with PM, or a customer ID will start with CUS. So as you can see here, there is some seemingly random values there, but they have this prefix that we understand as humans. This is great because it prevents one of the most important pieces of context from being lost, and it makes it easier for us humans to grok these IDs. Shopify uses a similar idea, but they do it a little bit differently. They use URIs to represent IDs in their GraphQL API. So you can see on the far end there, that is an example of a Shopify product ID, and it's a GID or a URI there. Personally, I prefer the prefixes because they're simple and a little more human friendly. Okay, so that was a history of IDs and where we're at with databases. Let's try building out this human-friendly version with UUID. I'm going to show you how we can leverage Ecto to build a system using prefixed UUIDs that are stored in the database in Postgres as binary UUIDs. And if anyone's not familiar, Ecto is a powerful framework for interacting with data and databases using Elixir. It's pretty cool. I'm still really new to it, but it's one of my favorite parts of using Elixir today. Okay, the fun part. So this is the command I use to build, I don't know if you can see it there behind the Zoom stuff, a new Phoenix app. So mix Phoenix new, I called it nice, that's the name of the app. I made one change here, which is the binary ID flag. And all that does is it says my migrations and my schemas should use a binary ID instead of an integer ID. The other thing I'm using here is a package called Ecto UUID. So instead of reinventing the wheel and ending up with a terrible triangle, we're actually going to wrap this library to support our prefix logic. We're going to be using this really neat behavior called Ecto parameterized type, which is similar to Ecto type. These things are really cool. This is where all the heavy lifting is done. And they allow us to define new database types that we can use to interact with Postgres and in our schemas and throughout the rest of our application. And they give us control over how they're serialized and deserialized. All we have to do is implement a few callbacks for behavior, and then Ecto takes care of the rest. And it's pretty seamless, which is awesome. So look over at our terminal. I've generated this app already. If I can find my cursor, let's make this larger. Okay, can we all see that? So I've generated this, like an hour before I came here, so it's pretty fresh. It's just a Phoenix app, like I showed previously, using 1.7. I've added that Ecto UUID dependency already, just make sure it's installed. Nice, we're all good. Switching back here. Let's get to our implementation. Can I change? Can I move that thing? Sorry, one sec. Let me see if I can do this. Nice. Okay, so for our implementation, we're going to create a module that implements these 5 functions. We'll go over them briefly afterwards when we look at the code, but there is type, and that actually returns the type that is stored in the database. That could be anything, an integer, string, blob of JSON, whatever your database supports. In it is just the initializer. So anything we need to set up, cast it to a given type with certain parameters attached to it, dumps it into whatever it's going to talk to the database in, and load does the inverse of dump, essentially. So let's implement this here. And luckily, we can defer all the heavy lifting of the actual UUID work to the Ecto UUID package, and we can focus purely on the prefixing, which makes it nice and simple. So in an effort to avoid embarrassment, I've already put this code in here, and we can take a look at it quickly instead of trying to code this module from scratch, because I will surely mess it up. I know looking at code on a slide sucks, so let's open up our terminal here. Oh man. Let's see here. Lib. Nice. So we have our library here. Let's look in. This is the root of our app where our code is stored. We just have our application, our mailer, and our repo. Let me figure out a way to do this from screen to screen here. Sorry, this is just going to take a sec. Okay, so let's add a new file in here. This is weird because I can't see this on my screen, so I'm doing this kind of blind. Yeah, it's really weird because of the editor that I use. And we're going to call this prefixed ID.ex. Nope, that's not what I wanted. Let's do that. Sorry, it's restoring a session of mine. Let's just do this the easy way. I'm going to paste this in. Okay. Let's start at the top here. So this is our module, and it looks kind of long, but it's pretty simple. We pull in our behavior, Ecto parameterized type. We pull in the things we need from Ecto UUID. So you'll notice that these are most of the functions that I talked about already: cast, dump, load. We define the type that's stored in the database, which is actually UUID. If you remember, UUID is binary compatible with UUID. Our init is our initializer, so it just does a quick check on our options to make sure that someone's passed in a prefix, which is required because this is a prefixed ID. We give a little warning if it's not, and otherwise we just pass on our options. So this will cast an input into a prefixed UUID. We basically just pass this we decode it using our function, and then we pass it to the Ecto UUID, and it does the hard work there. Our dumping does the same thing. We decode it, and then we call the Ecto UUID. Our loading does a little bit more. We try and load it ourselves, and then we encode it using our prefix. And I'll jump into these at the bottom. I'm going pretty quickly through this, but it might make a little bit more sense once we get there. So the 2 functions that we've seen throughout are this encode ID and decode ID. As you can see, they're pretty straightforward. We have our parameters, which were passed in as options, and we have the prefix, and we concatenate that with an underscore and the actual ID that's passed in. Our decode is very simple. We check that if the ID passed in starts with our prefix and an underscore. If it does, we remove it. Otherwise, we figure something might have gotten messed up there and we just ignore it. So these two functions here are essentially what does all of the heavy lifting in this file. And you can see it's pretty straightforward. There's like 3.5 lines of actual logic here, which is pretty cool. So let's save this file. Go back to our presentation for a sec. Okay. So that was a little dry, but that's pretty much all we really needed to do to implement prefixed IDs. So let's try and actually use this stuff now. Let's generate some resources. So we're going to use Phoenix scaffolding, which is really neat. If you guys haven't used it yet, it's super powerful. It lets you define your schema and it'll create a migration, a context file with all of your database operations with Ecto. It'll create your controllers and your views, your user interface. The one that I'm using uses Phoenix Live View. So let's create some humans. And here we're defining the modules and the context where it's going to live, the name of the table. We're going to say humans have a name, they have an alignment, which is an enum, they're going to be evil, good, and they probably have a birthday, right? That's like most people. So let's start with that. Let's generate some humans. Here we go. Let's clear our string. Okay, so, oh wow, this is so weird. We're going to copy our routes. It's also telling us that we need to migrate our database. So let's do that. Mix ecto.migrate. It's complaining because we haven't added our routes. Mix ecto. Let's do this. I think I may have neglected to create my database. So now let's migrate. Cool. Awesome. Created table humans, migrated successfully. Let's add our routes like it told us to do. Lib. So routes are under the web folder and it's in a file called router, suspiciously. And here's where we find them. There's only one default route created there. So let's paste these in. Obviously, we have to fix our indentation. Okay. And back to our presentation here. So we generated this resource. We followed the instructions. We haven't done anything different or strange yet. And the other thing we need to do is we need to tell our schema to actually use our prefix ID for the IDs. So if we open up our human schema, that should be under nice. It's going to be in that context we just created called humans, and it's going to be called human. So if you remember at the beginning when I generated this project, I said to use binary IDs. So it's saying here the primary key is a binary ID and the foreign key type, if we're referencing it, is also a binary ID. We're going to change that. We're going to use our prefix IDs. So let's delete that. And let's add in our alias. Okay, so we've added in an alias to our prefix ID module. We've changed this to say our primary keys are actually using prefixed UUIDs. We're going to auto-generate them instead of setting them manually. And our prefix is going to be HUMN for human. And same, our foreign key type is going to be prefixed ID. So let's save that. And let's now start our server. Man, I can't see what I'm typing there. Cool. So it started up on port 4000. Oh. Let me drag over a browser. Okay, awesome. So we have our default Phoenix set up here. Let's test it all out. Let's see how it works. This is the default page that we see there, the landing page. I can't actually see the URL, but let's do /humans. Nope. Nice. Okay, so this was all auto-generated for us. This is that scaffolding I was talking about. It's really cool. We have like a whole working CRUD app with one command line call. Let's see if we can create a new human. Let's say Mattia. There he is. Alignment, obviously evil, and he was born today. Oh, this is blank. He was born yesterday. Even though he will claim he wasn't born yesterday. So here we have a human that we've just created. And here, by default, it lists the ID. And so this is just calling human.id here. Oh man, I wish I could show the URL. Does anyone know if it's possible to move this thing?
Yeah, you got. You're gonna have to grab it in a weird spot. I can help.
Oh,
Yeah, there you go.
nice, nice. Okay. So as you can see, our prefix is here on top of this UUID, which is all auto-generated for us. If we look at the URL, it's in the URL too. There's nothing fancy we had to do there. We didn't have to teach Phoenix how to thread this through. Let's actually quickly look at our database as well, just to see, just to verify. Let's look here. Nice dev. Let's look at our humans. Here we are. We have Mattia, who's very evil, born yesterday, and his ID is a UUID. You notice it's formatted actually differently than what we saw on the screen because of the encoding. This is not base 32. This is the traditional UUID hex encoding. And if we check out our schema here, whoops, that's not what I meant to do. But yeah, this shows us the same information. So ID is a UUID here for our primary key, which is awesome. Yeah, and we'll switch back to the presentation. Okay. So we've already tried it out. We didn't have to make any other changes. This is using the auto-generated Phoenix scaffolding. We simply had to tell our schema to use our prefix ID module for the ID. That was pretty much it. We didn't have to make any other changes. Everything already knows how to speak this. There's no other things we need to teach it to use this. But now everywhere in our system, we have these cool prefixes that are sent out. People can share these IDs back and forth. And we have all the benefits of the binary IDs and all the benefits of this human style ID. And everything seems to just work, which is pretty cool. And yeah, that's it. Thank you. I don't know if anybody has any questions or comments. And that's my Mastodon if anybody wants to follow me or ask questions there.
Thank you. Yeah, let's see if we have some questions here, and then I'll also check the chat. Chris.
All right, let's say you already have a table with UUIDs.
Yes,
This would just work with that.
exactly. It's backwards compatible, which is really cool. So ULID, you can add it on top of any UUID. Or if you decide that this is overkill and you don't want it later, you can rip it out and just use UUIDs directly.
Yeah, so the advantage of doing this decoding and encoding is like a way to obfuscate IDs from, just like.
Yeah, so that's an advantage of using opaque IDs. UIDs, ULIDs, object IDs are an example of that. They do have a structure which you can decode with enough know-how, but for most cases, it's sufficient. UID 4 is completely random, so that one is much more difficult. Yeah, and the advantage of the prefix, like I was mentioning, is it's for humans, but you can do some really cool stuff with it. So for example, Stripe on their dashboard, if you paste an ID in, it knows exactly the resource type to load. So if you paste in an ID for a payment method, you can actually just hit enter and it'll bring up that payment method. It doesn't have to ask you, oh, are you looking for a product? Are you looking for a customer? So it's pretty cool. It's very powerful. You can do the same type of thing with log parsing too, or incident reports if you have to add links to things or add more context. So it's pretty neat.
One quick question.
Yes,
Have you looked at the ULID library? Is it actually using parameterized types as well? Like, is it turtles all the way down?
yes.
Okay.
Yeah.
Cool.
Yeah.
That's fun.
I'm thinking I might try and pull request the Ecto UUID library. It hasn't been active in a while, so if it hasn't, maybe I'll release something. But yeah, I was thinking about adding it back.
Oh, cool. Sweet.
But yeah, like you mentioned, this type and parameterized type behavior from Ecto is super powerful. It lets us wrap essentially anything and be completely transparent.
Yeah, like obviously totally different talk, but like hearing you talk about it, like transparent data encryption, right? Like you could be encrypting PII using that on its way in, like
Yeah,
there's a bunch of cool stuff that you can do.
it's really cool.
I have
Yeah.
some ideas. That's awesome.
Yeah, cool. Yes. No, that's it. All you have to do is that initial command line switch. If you don't do that, it's a one line config change. So you just say use binary IDs instead of anything else. If we want, I can quickly show you the migration that's generated. Well, let's take a look at this. Repo migration. We only have one migration here. So this is the migration that was auto-generated for us when we used the scaffolding. And because we told a Phoenix and Ecto to use binary IDs, it put this here for us instead of an integer. But that's it. That's really the only change that needs to be made aside from our module that we implemented. It's pretty cool.
Cool. Chris?
So this is completely compatible with Ecto's query language, like if you're to search on the ID column or where ID starts with humans.
Yeah.
It would work.
Yeah, absolutely. Because of the parameterized type and the casting, the dumping, and the loading, it will convert it to the right value at the time that it actually runs the query. And the cool thing about our module that we implemented is that even if it doesn't have the prefix, it just spits out the ID. So in most cases, if you pass in a ULID or a UUID, it will just work. So you can use any of these and it knows what to do in that scenario, which is super powerful and very flexible. I mean, that was up to us. That was a decision we made, but it was very easy to do. It was easier to do than not to do. But as you can see here, this is our context that was generated for us. We didn't change it at all. So here is our get by ID. And the example template has integers in there because that's the default. This is already passed in from our controllers as a string with the prefix, and it already knows what to do here with our repo.get. There's nothing else we have to do there, which is cool. And if we decide to rip it out and just use ULIDs or UUIDs, there's nothing we have to change there either.
Cool. Two more questions from me. One is.
So
I
I
wanna have.
Sorry, I think someone's asking a question on the
Yeah,
chat.
go ahead.
Sorry, go ahead.
Yeah, can you please go to the migrations once, and why do we define the primary key as false and then we define the primary key as true?
That is done automatically. Oh, sorry, I'll repeat the question. Why do we define primary key as false in our migration and then add it manually again here? This is auto-generated for us, and it's because of the configuration change we made to binary IDs. We can configure it to, I mean, we did automatically configure it to use binary IDs instead of serial integers, but the scaffolding is not smart enough to know that and omit this. So it adds this in for us. You could also do this manually if you wanted to use different types of primary keys in your migrations that were not the default for your app. Does that answer your question?
Yeah, thanks.
It's just a symptom of us changing the default. And the code templates not being smart enough to understand all of it.
Okay, two things.
Yes.
I want the list of all the fancy bash tools that you're showcasing this presentation.
Yes.
Like, we'll put it in the YouTube video notes
Yes.
afterwards. And yeah, please, like if you, when you publish the code for this, let us know and we'll put it on the Slack and stuff. Okay?
Yeah, I will throw it up in a repo and I'll share my tool. My dot files are open source.
I know.
Yeah.
I know.
Yes.
Okay, thank you so much.
Thanks, everyone.